Good evening, this is Mr. Wintermelon. So in the past few videos, we have explored reflex action and go through a few examples such as touching a hot object or the dilation and constriction of our pupil when our eyes are exposed to light of different intensity. So in this last video, we are going to learn about focusing, which is not a reflex action. It is a voluntary action. So by the end of this video, you should be able to describe the structure of the eyes as seen in horizontal section. Because when we are talking about focusing, our focus will be on the horizontal section of our eyes. You will also need to be able to state the principal function of the component of the eyes in producing a focus image of near and distant object on the retina. So we have learned about reflex action. Now let us learn about voluntary actions, which is focusing or accommodation. So focusing is the adjustment of the lens of the eyes so that we can see a clear image of objects that are different distance from our retina or from our eyes. So you might be thinking, so how are the lenses adjusted? But first, we need to learn about the horizontal section of the eyes before we focus on focusing. There are two rectus muscles that you can see. When we want to look up, the rectus muscle on top will contract for us to look up. When we want to look down, the rectus muscle below will contract, pulling the eyeball down. So this function is important, you have to know. Normally, they wouldn't show this rectus muscle that is at the side because it will cover the important thing called the lens. So this rectus muscle at the side will allow our eyeball to swing left and right, left and right, and left and right. So those are the rectus muscles. You need to know what happens when each of them contract. But it's not difficult to imagine what will happen because the muscle on top contract. You can imagine it pulling the eyeball to look up, and when the one below contract, you can imagine it pulling your eyeball to look down. So this is just a minor part. Possible to come out, you will have to know. Next is mostly for your information as well. The cornea is a transparent layer that reflects light into the eyes. It is responsible for most of the reflection that occurs in the eyes. So you can see a layer in front of the eyes, then you can see it from the cross-sectional diagram. Aqueous chamber that also helps to reflect light. The lens, which is the most important structure that you have to know. That's why I said it's mostly for your info. But the part on lens, you have to know because it is elastic, so it can change the shape in order to focus light into the retina. So unlike the other components such as cornea, aqueous chamber, and vitreous chamber is the liquid that is behind the lens or inside the eyes. If any of you have eaten the fish eyes, you should notice the jelly-like substance in the fish eyes. And the variable that causes the amount of light to bend, I will talk about the bending of light a bit later, is the lens. For cornea, aqueous chamber, and vitreous chamber, the amount of light they can refract is more or less fixed. So let us take a look at what happened during refraction of the light. So we have light coming in. The cornea will reflect the most light aqueous chamber, it will refract the light again. Refracting of light means the bending of light, if you do not know. Then when it reaches the lens, it will refract again. And finally, it will be focused on the back of the eyes, which we call retina. So the retina, they are actually light receptor. They are sensitive to light, which is why we call them photoreceptor. There are two types of these receptor in the eyes. They are called rod and cone. So the rod photoreceptor is more sensitive to white light. Black light, that means there's nothing. While the cones actually give us our color vision. Fovea, which is where images are normally focused. We have our optic nerve, which is a sensory neuron. This is very important. It is called the ciliary body. It is the muscle that is over there, as you can see, and it is tied onto some string-like structure. They are called the suspensory ligament. So these two ciliary body, suspensory ligament, are very important. And what is this hole down here called? It is actually our pupil. And the muscle on top and below, it is the iris. And the muscle surrounding it is actually our iris. So some extra information. For cones, there are three types of cones: red, green, and blue. But the name is very bad because it is not like they only absorb red, blue, and green. They can absorb lights of a wide range of wavelengths, just that they are more sensitive to red, green, and blue light respectively, depending on which type of cone they are. They operate well in bright light, while for rod, they are more numerous and more sensitive, so they can actually work well in dim light, but they will only allow us to see in black and white. So focusing on the main task at hand, focusing will involve ciliary muscle, suspensory ligament, and our lens. So when you are answering question, make sure you have the three terms down there. If not, there's no way you are going to get full mark. When we are focusing on a distance object, which is 7 meters away, our ciliary muscle will relax. Suspensory ligament will become stretched, and the lens is pulled and become thinner and less convex. Photoreceptor in the retina is stimulated and nerve impulses are produced and transmitted to our brain, forming the image. Now here is where I want to bring out a story, a short one, so that it is easier for you to understand, or to a lesser extent memorize. Now, when Mr. Wintermelon is doing recording, he will spend a lot of time looking at the computer. Then Mama Melon will ask Mr. Wintermelon to go and look at the grass to relax my eyes. Now, the reason for her doing that is because she thinks green is good for our eyes to make us relax. But I'm trying to think of why. Maybe it is because when I'm looking at grass, it is more than 7 meters away, because I will be staying in my house rather than going out exposing myself to the hot sun. So in a way, how I remember the ciliary muscle relax when we are focusing on distant object is this. Because we want to relax our eyes, we look at the grass that is a distance away. So when we are looking at distance object, our ciliary muscle will actually relax. And when our ciliary muscle is being relaxed, they actually become shorter. So imagine you are stretching, you are relaxing, stretch your arms. So when we are stretching and relaxing, it will pull the suspensory ligament. And this will in turn cause the lens to be pulled and become thinner. For the opposite, when we are focusing on nearby object, same set of muscle as well as ligament and lens. And like I said, it's the opposite. So for far away cases, our ciliary muscle will relax. Object that is nearby cases, our ciliary muscle will contract. So when the ciliary muscle become contract, the suspensory ligament will become slackened, and lens will become thicker and more convex. So everything else is the same. You just have to take note that it is the opposite of far away object. Far away meaning 7 meters or above. So how do we remember this? I would say it's not about memory. You can, but the idea here is to play smart. You know that for distance object, ciliary muscle will relax because Mr. Wintermelon looking at grass that is far away. So far away to relax my eyes, ciliary muscle will relax. That is for distance object. For nearby object, it will be the opposite. Everything is opposite.
So let me just summarize. Imagine this rubber band is your lens. If we are looking at something that is further away, our ciliary muscle will relax because we are staring at grass. So we relax like Snorlax that is stretching. So since it is stretching, it will stretch the suspensory ligament, which will pull the lens. So you can see that originally the lens is like this. When it is pulled, it becomes thinner. When it is pulled, it becomes thinner because the ciliary muscle is relaxing. Now, when we are looking at something close by, our ciliary muscle will contract. So contract is like someone that is flexing their muscle. So flexing, like that. So the suspensory ligament will slacken and we will cause the lens to become wider and more convex.
Lastly, let us do a comparison between the similarity and later on the difference between our nervous control as well as endocrine control. So what are the similarities? Both requires a detector. For example, for nervous response, maybe a change in light intensity. Endocrine response, a change in blood glucose level. Both require a signal to be transmitted. In nervous system, it is through action potential or nerve impulse. For endocrine control, it is through hormone or chemical. And lastly, for both, at the end of each response is an effector or target organ, such as our muscle or our liver. The differences, there are quite a few. For nervous control, it involves neurons. For endocrine control, it of course involves hormones. In nervous control, signal is transmitted by electrical means as well as chemical means, but for our hormonal system, it is through chemical in the form of hormone. For nervous control, the chemical part is the synapse part, which I said, well, honestly, is not really inside your syllabus. So you can just stick with electrical transmission, which is our action potential. So for nervous control, nerve impulse is transmitted by neuron, while hormones are being carried by blood. For nervous control, the response is normally rapid. For endocrine control, normally is slower. And even for fast endocrine control, they are still relatively slower than nervous control. Nervous control often cause short-term effect, such as our pupil dilation or constriction, while for endocrine control, it can be long or it can be short. For example, growing during puberty, it is caused by hormones. And the long-term impact is you become taller or you have bigger boobs. For short-term control, let's say your blood glucose level return to normal. For nervous control, it can be voluntary or involuntary. Endocrine control is always involuntary. For example, we cannot control our ADH. Actually, we can kind of control by drinking a lot of water, but we cannot stop it from producing less. That is what I'm trying to say. And lastly, nervous control is usually localized. That means if I want to move my hand moves. My leg kind of doesn't move together with my hand. For endocrine control, it can be widespread. For example, insulin can cause various parts of our body to absorb back more glucose from the blood. And that will be all for this chapter.